डियर स्टूडेंट्स अस्सलाम वालेकुम। हमारा जो आज का टॉपिक है दैट इज़ ग्राफिकल रिप्रेजेंटेशन ऑफ अ पेयर ऑफ लीनियर इक्वेशंस एंड एग्जिस्टेंस ऑफ सॉल्यूशंस। यानी हम जब एक पेयर ऑफ लीनियर इक्वेशंस को ग्राफिकली रिप्रेजेंट करें, यानी उनके ग्राफ्स को प्लॉट करें और उस तरीके से हम सॉल्यूशंस कैसे डिटरमाइन करें, तो ये जो हम यहाँ पे सीखेंगे इस टॉपिक में ग्राफ्स की मदद से हम कैसे सॉल्यूशन फाइंड आउट करते हैं। सो वी विल लर्न द ग्राफिकल मेथड फॉर फाइंडिंग द सॉल्यूशंस ऑफ अ पेयर ऑफ लीनियर इक्वेशंस इन टू वेरिएबल्स। इससे पहले कि हमने अपने क्लास 9th में ग्राफ ड्रा किया होगा, प्लॉट किया होगा ग्राफ फॉर a single linear equation in one variable, not a pair, but I am talking about the pair of but a single linear equation for the graph of a single, that is if you have a linear equation in two variables equal to 0, it is a single linear equation. This is a linear equation in two variables x and y. It is a general form of a linear equation. When we plot the graph where a square plus b square is not equal to 0, that is both a and b are not equal to 0, and a, b, c are constant, that is real numbers, and x, y are variables, these are variables. So when we plot a graph for such an equation, the graph comes out to be a line. For example, if you plot a graph for this equation 2x plus 3y equal minus 5 is equal to 0, so its graph will be a straight line. So when we plot a graph, the graph will be a straight line. Okay, it is graph. Let me graph will be a straight line for such an equation in two variables, a single equation I am talking about. So a line, straight line like this, you will come across, you will find a line in your graph, and एक लाइन में every solution of the equation, for example, if is the graph of your equation, it is your equation, if it is the graph of your equation, every solution of the equation is a point on the line. So a line has infinite number of pointers. Every point on it will represent the solution. Every point on it, every point on the line representing an equation ax plus by plus c equal to 0. This linear equation in two variables is a solution of the equation. हर पॉइंट जो इस लाइन पे होगा, वो इस इक्वेशन का सॉल्यूशन होगा, जिसको वो रिप्रेजेंट करता होगा, मानो जिसका वो ग्राफ होगा। तो यहाँ पर हर जो पॉइंट होगा इसके कोऑर्डिनेट्स होंगे, इट हैज़ कोऑर्डिनेट्स एक्स वाई, टू कोऑर्डिनेट्स, तो वन ए वैल्यू एक्स का होगा, एक वैल्यू दूसरा वाई का होगा, जो इस पूरी इक्वेशन को सेटिस्फाई करेगा। तो इस तरह से इस पर जितने पॉइंट्स होंगे, सो लाइन यू नो हैज़ इन्फिनाइट नंबर ऑफ पॉइंट्स, infinitely many pointers line has. So a single equation, so ax plus by plus c, where this a and b are non-zero, has infinitely many solutions. So what we conclude out of is that a straight line represents the graph of a linear equation in two variables, and every point on that line is a solution of the equation. Since a line has infinitely many pointers, so a linear equation in two variables like this will have infinite number of solutions. Infinite number of solutions line has. So a linear equation in two variables will have a single linear equation. Now let us look into the graphs of a pair of linear equations in two variables. What about a pair of linear equations in two variables? Pair of linear equations in two variables. We know how can we represent the solution of a pair of linear equations in two variables. The solution of a pair of linear equations in two variables will be a point. When we draw the graph, when we plot the graph of two equations together, there we will get two lines, and the lines will meet or intersect at a point, at a common point. This common point will have coordinates x, y, and this will be the solution of pair of equations. If you have an equation a1x plus b1y plus c1 equal to 0, and it is the graph of another equation a2x plus b2y plus c2, then the lines meet at a point. The common point will be the solution of both the equations, and that is to the p of the pair. So the solution of a pair of linear equation in two variables is a common point of intersection, or we can say the common point of both the lines, a point of intersection, or point of intersection of graphs of lines representing equations will be the solution of the two lines. Will be the solution of the two equations which they represent. Now when we plot the graphs of a pair of linear equations, in two variables, what will happen? three things can happen, three cases can happen. Number one, the lines will intersect at a point. The lines will intersect at a point like this, somewhere. For two equation, equation 1, this will be the graph of equation 2. So lines intersect at a point, so we have a solution. So in this case, the equations 1 and 2 will have unique solution, that is one solution, exactly one solution, exactly one. That is unique, we call it unique solution. And the solution will be given by the coordinates of the point of intersection, that is the common point in the two lines representing these two equations. तो यहाँ पर आप देखें जो पॉइंट ऑफ इंटरसेक्शन है दो लाइन्स का, जो ग्राफ्स हैं इन दो इक्वेशंस की, तो वो इसका वो एक सोल्यूशन होगा इस सूरत में. तो उसको उस वक्त अगर ऐसा नहीं है, इफ इट्स लाइक दिस, इफ द ग्राफ्स of the two lines coincide, in the second case it can happen ऐसे होगा, and the second line will coincide the first graph, it's like this. So what happens, for example, if the black colored line I draw is the graph of equation 1 and this is the graph of equation 2, this one, then both the lines coincide. In this case it becomes a single line, and single line, every point on this single line will represent a solution of a pair of equations. So it will be every point, so it has infinite number of points on it, so we can say that the two lines have infinite number of common points. In this case two lines has infinite many common pointers, and the common pointers between two lines represents their solution. So in this case infinitely many solutions, infinitely many solutions, and the two equations in this case are said to be consistent. Consistent and dependent. Consistent and dependent. We call them as consistent and dependent equations in this case. Equations. In this case, in the previous case, the equations are said to be, in this case, if they have only a unique solution, equations are consistent. We classify them as consistent and dependent. And then in the third case, if the lines, that is the graphs of two equations, are parallel lines like this, so it is equation 1, for example it is equation 2, then the two graphs do not meet at all, so it, in this case no solutions can occur, no solutions. The two lines will have no solutions, and the pair of equation is said to be inconsistent. Inconsistent pair, we call them as inconsistent pair. So when we draw the graphs of two equations together, that is a simultaneous pair, we can come across three cases. Either the graphs will meet at a point then the equations will have only a unique solution and equations are said to be consistent. Number 2, the graphs of the equations coincide. If the graphs of the equations coincide, that is, we will have in this case infinitely many solutions, and the equations are said to be consistent and dependent. In the third case, if the graphs of the equation are parallel, then they will not meet at any point, so in this case they will have no solution, and the pair is said to be an inconsistent pair. So this is all about the graphs and the existence of solutions of a pair of equations. We got a clear. Now we can represent graphically a pair of equations and find their solutions in this way.